To choose a topic that interested us for this year's STEM research project, we split science into 3 topics as well as analysing data separately to give us a better perspective. In the end, we settled on choosing outer space colonisation in the area of physics and came up with the thesis, can we develop the technology necessary for humans to colonise Mars?
In order to become more familiar with the topic, we decided to research into some existing case studies. I researched into the 2-part ExoMars mission. In 2016, the European Space Agency launched a trace-HAZ orbiter with a micro-ARES to measure radiation in the atmosphere, and a surface rover with a neutron spectrometer to detect aquifers.
In 2013, the Mars Atmosphere and Volatile Evolution satellite was launched to analyze the Martian atmosphere for trace gases using an NGMIS to measure gas hydrogen potential and an LPE, which uses electron volts to measure the power of harmful ultraviolet light penetrating the atmosphere.
In 2003, NASA launched the Mars exploration rover Spirit and Opportunity to search for metals, chemicals, and H2O isotopes inside Martian rock cores. Their main sensors included a mass bar spectrometer to search for ferrospace and an X-ray spectrometer to visualize internal soil content.
We decided to research into some factors that will be harmful to humans when colonizing Mars. We discovered that Mars has higher levels of radiation than Earth, a lack of an atmosphere, frequent solar flares, and extreme climate.
They're only sustainable if they're managed sustainably, so you have to think about the rate of extraction of water versus the rate of how they're naturally replenished. So aquifers are obviously groundwater stores, so you have to think about how much water is infiltrating through from the surface of the ground and down into the groundwater store.
Usually the problem is the availability of the power source, so if you're going to use a temperature difference, you need to have a temperature difference. So you have situations like geothermal power where you can have hot rocks under the ground and cold air at the surface, and then that gives you a permanent temperature.
In order to further our research process, we contacted Dr. Tim Sands, a renowned geologist from the University of Hertfordshire, and asked him questions about the mineral content of soil and rocks in Mars.
As explained before, we plan to use thermoelectric principles to power our colonies on Mars. This is a computer-aided design model of what we expect our power supplies to look like when they are created and mass-produced. Thermoelectricity works by using temperature difference to circulate electrons and protons to generate electricity sustainably. We plan to create robots like these, which have drills to access aquifers, sensors to search for them, as well as drills to access hot rocks to produce thermoelectric differences.
We created a unique web app that contained a quiz. The quiz would assess the health of the user by asking questions about their heartburn, physical weakness, breathing issues, and many more things. It output the results in the form of a pentagon chart and compared this to many existing ailments in order to correctly diagnose them. We also created a chatbot which also did the quiz. However, it outputted the results in the form of a code. The code could be used on our website to check what the results are, as well as be given to a doctor in Mars while a person is living in Mars, in order to fully give their symptoms to the doctor.